Hello guys, I will try once again to make a brew like math. It is the second part of the explanation about the greatest common divisor, and we will be talking about prime numbers and least common multiple as well. The next video in this playlist will be a beautiful song to help fix the content. So in order not to miss the launch of it, subscribe to the channel and activate the bell. One more thing. The music next video will be full of metaphors, and to understand them, you need to watch the video until the end. See ya! I don't know if you noticed, but all the values that I show in the deliveryman example are the same values that the question for the teacher used. Pizza, Japanese food, and ice cream are the bars that will be divided into equal parts. Gemstones are the options that the question gave you as to which would be the greatest common divisor.
Look, that's right. If I have known that, I would have been wrong. I would have, right away, discarded the values of the question that I guessed and missed it.
In a test, you will not be able to guess several times. You have to get it right the first time.
How am I going to do that?
Let's talk about that question. You said you used what I taught you, but it didn't work. You found the chest and the key correctly, but you didn't understand what the key meant, and it was referring to the greatest common divisor. Different bars divided in equal parts. There is a piece size that can fit perfect on all bars. And in my example, there is a gemstone that can pay for all three orders, without the need for change. Is it possible to get the question right without knowing what is the greatest common factor? Yes, it is possible. For example, if you are an appliance student and already know the multiplication table by heart, you will already be able to discard some alternatives right away, because you will know that they do not meet what the question asks. If you're bad at multiplication tables but good at interpreting questions, you'll also be able to rule out some options by logic.
And if you're bad at both, what do?
Then you try to find out by brute force, testing the alternatives one by one. If you are unlucky, it will take a lot of your time. Or you use the technique that I will teach you, that will make your life easier. In mathematics, you can't count on luck, or as you did, keep using tricks to guess. The question you are trying to solve was created by a feline, just like you and me. Try to put yourself in her shoes. Try to guess what she's wanting you to use. Use your imagination not only to make the study more enjoyable, but to think as the teacher thinks. This question talks about equal parts of the largest possible size. Every time you see these terms, there is a 99% chance that the question is asking if you know how to use the greatest common factor.
Okay, you convinced me. Talk about the secret technique.
Well, it is nothing more than using the least common multiple in a special way. While the least common multiple uses democratically multiplication of prime numbers to find the answer, the greatest common divisor selectively uses multiplication of prime numbers to find the answer.
Why do you torture me with difficult words?
Don't you know what prime numbers are?
No, I don't know. Why? Are you prejudiced?
No, of course not. Let's learn them. Prime numbers are numbers that can only be divided by 1 and by themselves, so that there can be no remainder, nor the answer be a decimal number. For example, see number 7. In addition to the 1, there is no number smaller than him that can divide it exactly, without leaving any remainder or giving a decimal answer number. The number 8, for example, is not a prime number. It can be divided by 1, 2, and 4, in addition to itself. There are many prime numbers, but most questions use only the first 4.
Well, lucky us!
To find the greatest common divisor, you need to master the least common multiple technique. Both will use prime numbers. While one is simpler but takes more work, the other is more complex but quicker to solve. You will already understand what I mean. In the least common multiple, what we want is to find out what is the smallest possible number that we can find and that can be divided exactly by the 2 or more numbers that the question gives you. Let's imagine that another similar question asked for the minimum common multiple of 120, 160. I will now ask you to write it down. This will make it easier to remember at the time of the exam. To do the math, we need to put a number to the right of the other and a big dash to the right of every one. We start by trying to divide an all by the smallest prime number, which is 2. Place 2 to the right of the dash. Those who can divide, you will put the answer under each one. The ones you are unable to divide, you will copy the number again below. All of the numbers end with 0, which is an even number. They're all even then. Every even number can be divided by 2. 120 divided by 2 gives 60. 100 divided by 2 gives 50. 60 divided by 2 gives 30. You cannot move on to the next prime number without making sure that any number can be further divided by the current prime number. We will try to divide again by 2. The three numbers also end with 0. They're also even. 60 divided by 2 is 30. 50 divided by 2 is 25. 30 divided by 2 is 15. Notice that now only the number 30 ends in 0. The other two ends in 5, which is odd. Remember what I said, as long as there is at least one number that can be divided by the prime number previously used, you cannot move on to the next one. Since 30 is even, we need to keep using number 2. 30 divided by 2 is 15. 25 can't be divided, so pass it down. 15, 2. Now all numbers are odd, so none can be divided by 2. Let's move on to the next prime number, which is 3. When you have a number of 2 or more digits and you don't know if it's divisible by 3, just add the digits. 5 plus 1 is 6, double 3. 15 is divisible by 3. 2 plus 5 is 7, which is not divisible by 3. 25 is also not. 15 divided by 3 is 5. The 25 will not be divided, so pass it down. Neither 5 nor 25 can be divided by 3 without giving a remainder or decimal answer. Let's go to the next prime number, which is 5. 5 divided by 5 is 1. 25 divided by 5 is 5. All the numbers could be divided. As you can see, we still have a number that can be divided by 5. The others will just pass down. When you have reached the point where you only have number 1 under all the terms, you have come to the end of the divisions. Now it's time to multiply. Let's multiply all the prime numbers we used, one by the other. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 5 is 120. And 120 times 5 is 600. You may have found it somewhat difficult to multiply in the sequence in which the prime numbers are arranged. No problem, as in addition, in multiplication the order of factors does not change the product. This means that you can multiply any way you want, as long as you don't neglect or use the same factor more than once. For example, we can do 2 times 5, that's 10. 2 times 5, that's 10 again. 10 times 10 is 100. Only 2 and 3 left. 2 times 3 is 6. 6 times 100 is 600. Oh, that looks a lot easier. Indeed, and now we know that the least common multiple of 120, 100, and 60 is 600. That means that the smallest number that can be divided by both 120 and 160 is 600. In that question, those numbers would be the chest and the key would be the least common multiple.
Look, but that number is quite large. Is that the answer to the question?
Of this question that I invented, yes. But your Twitter's question is asking for the greatest common divisor, not the least common multiple. And the greatest common divisor follows the same steps as the least common multiple, with the exception of one. Instead of multiplying all the prime numbers used in factoring, it multiplies only those who manage to divide all terms in their turn. To make it easier, we'll call them optimus prime numbers.
Oh yeah, I like transformers!
The others that have not been able to divide all the numbers we call bumblebee numbers.
What that? Don't you like Bumblebee?
No, Optimus Prime is much stronger. The first prime number, 2, managed to divide all the 3 numbers. He is Optimus Prime. The second prime number, 2, also managed to divide all 3 numbers, Optimus Prime 2. The third prime number, 2, only managed to divide one number, the 30. He is Bumblebee. The fourth prime number, 3, only managed to divide 2 numbers, the 15. He is Bumblebee. The 50 prime number, 5, managed to divide all the numbers. He is Optimus Prime. The 16th prime number, 5, only managed to divide one number, the 5. He is Bumblebee. Right? While the least common multiple uses both Optimus Prime and Bumblebee to multiply, the largest common divisor uses only the numbers Optimus Prime to multiply. So, least common multiple, multiple transformers to 5. Greatest common divisor, it divides the friends. Do you get it? Whoa, what a genius! Oh, come on. Are you still mad because I prefer Optimus Prime?
course! Bumblebee is much more stylish! He's yellow, using music to talk!
Oh, do you like music? I will sing for you then.
Oh no, please no!
Ho ho ho! Just like in soap operas, I left the best for the next chapter. So if you want to watch me play a parody of the famous song Fly Me to the Moon by Frank Sinatra, subscribe to my channel and activate the bell, so that when I release it, you will be notified. See ya!